Welcome friends to the biologist. So today we are going to discuss pH electrophoresis. So this is how the pH electrophoresis looks like, and what are the things we use for pH electrophoresis. We can see here. We can see negative electrode, and we load the samples in the well, and there is a stacking gel, running gel, positive electrode, glass plate, spacer, and this is an illustration for the apparatus used for the SDS page. In native polyacrylamide gel electrophoresis, proteins are applied to a porous polyacrylamide gel and separated in electric field. When proteins are placed in the electric field, molecules with net charge such as proteins will move forward one electrode or the other, a phenomenon known as electrophoresis. There are different types of page in which native page the molecules separate in the electric field or on the basis of their charge and protein. Since the electrophoresis separation is carried out in a gel which serves as molecular sieve. Some molecules move faster through the pores as compared to large molecules. The gels are made of polyacrylamide, which is chemically inert. It is readily formed by the polymerization of acrylamide. Choosing an appropriate concentration of the acrylamide and the crossing linking agent methylene biacrylamide can control the pore sizes in the gel. The higher the concentration of the polyacrylamide, the smaller is pore size of the gel. The gel is usually cast between the two glass plates of 7 to 20 centimeters square, separated by a distance of 0.5 to 1 millimeter. The protein sample is added to the wells in the top of the gel, which are formed by the placing a plastic or Teflon comb in the gel solution before it sets. Procedure: set up gel, load buffer, get your sample obtained from the previous purifying technique, load sample, run gel, stain and look at with the UV light. A bromophenol blue dye is mixed with the protein sample to aid its loading onto the gel. Because a bromophenol blue dye is a small molecule, it is also migrates quickly through the gel during electrophoresis, thus indicating the progress of the electrophoresis in the simple native page buffer in the same upper lower reservoirs and in the gel with the pH of approximately 9, such as that most proteins have net negative charges and migrate towards the anode in the lower reservoir. An electric current is applied across the gel from the top to the bottom for a period to move the protein through the gel. When blue indicator of bromophenol dye reaches at the bottom of the gel, electric current is switched off and gel is removed from the electrophoresis apparatus. The gel is stained and the protein bands within it are visualized. A modification of page is SDS page, sodium rhodosyl sulfate page. In SDS page, the protein sample is treated with a reducing agent such as mercaptoethanol or dithioerythritol to break all disulfide bonds. It is then denatured with SDS, a strong anionic detergent which disrupts nearly all the non-covalent interaction and covers them with an overall negative charge. Approximately one molecule of SDS bind via its hydrophobic alkyl chain to the polypeptide backbone for every 2 amino acid residues, which gives the denatured protein a large negative charge that is proportional to its mass. The SDS protein is mixed and with the bromophenol blue dye and applied into the sample well, and electrophoresis is performed as per the native page. As all the proteins now have an identical charge to the mass ratio, they are separated on the basis of their mass. The smallest portions move farthest. Thus, if proteins of known molecular mass are electrophoresed alongside the samples, the mass of unknown proteins can be determined. SDS page is a rapid, sensitive, and widely used technique from which one can determine the degree of purity of a protein sample, the molecular mass of unknown sample, and the number of polypeptide subunits within a protein. Thank you. Please subscribe our channel.